Okay, welcome to my demo of my toolkits. So, the first tool I'm going to show you is very old. It's Verse, which is a real-time networking protocol for 3D graphics. And it looks like this. It's very exciting. What's cool about it is it allows you to store data in a server and then accesses it using UDP networking. So here is my, let's see, yeah, here's a nice tool I can show you. So this is my modeling tool, which is the first thing I'm going to show. And I've actually uploaded a bunch of geometry to this. So here's a piece of geometry. And I'm going to just show you what Verse is, start a second copy of the same application, like that. And now if I select something here, you can see both of them are synchronized. So this is used for all my games, all my content, and pretty much all my tools. And it's really, really neat when you don't have to save files because you just hook up to stuff and it works. And when you make a change somewhere, it just reverberates throughout the system. So actually, I'm gonna just go here. So I want to show you this modeling tool. So this is a subdivision surface modeler, but also can be used as a poly modeler. It models triangles and quads. And I'm going to create a new piece of geometry, and I'm going to draw something. So the first thing you do is you realize there's no interface, and everything is sort of just working with a model. So if I drag a line, you get a line. Here's a 3D line. I used the right mouse button to pan and around the camera. So now I've created a surface. So this is a poly, and of course I can draw inwards. So I use these guidelines to draw in XYZ. And I can also, while I'm drawing here, press the right mouse button and snap. So now I'm snapping to that point. So this point is now right underneath that one. So there you go. So now you can see it's a subdivision surface shape, and I can draw a little bit more and get a shape like this. So this is all like soft surfaces. So you can of course redraw a line and get a sharp crease. And actually, you can see the rendering engine is pretty cool because it actually doesn't tessellate where it doesn't need to. So this one gets pretty neat that way. So you can actually use the tessellated models in something like a game where polygon counts matter. So other things you can do is, for instance, if you want to split something, you just click on an edge and you drag. If you want to delete something, you cross it out. If you want to select something, you just draw a lasso around it, and now I can move it. I can rotate it, I can scale it, I can scale on one axis. And when I do any of these, if I press the middle mouse button, I can do an extrude. So it's really easy to build some kind of shape here. I don't know what this is. There's a little bit of buggy lines there. But this means you can really easily sketch things. And I read an article about the guy who did Pong, and he said the greatest thing about Pong was that it was one-handed because it was a bar game, so you could hold a beer or a girl while playing Pong. And so I designed this whole app actually to be one-handed, so everything is mouse. And I find it really useful if you're in boring meetings because you can sketch and you don't look like you're doing anything, but you can actually do everything. So no one will be mad at you. And this application has a lot of very sort of fine features that you would use as a proper modeler. So for instance, there's many ways of doing the same thing. So for instance, I did a selection, so you can do a selection like that. But you can also do a selection and go back to the start and say deselect. So now I deselected those vertices, so you can do those kinds of things. You can click on a vertex to select it. You can click on a polygon to select all the vertices in it. And I've tried really hard. When people design interfaces, they often think about like, how are we going to do really, really complex stuff, right? Because that's what artists usually ask for. They're like, we want to do a billion polygons, or we want to do this really intricate thing. And I find that those are useful, but what you really need is the thing you do 99% of the time. That needs to be incredibly efficient. And if you can save a click here and there, on simple actions like moving vertices, that's incredibly powerful. So I really thought about that. So for instance, in this application, you don't have vertex selection, edge selection, and polygon selection. You only have vertex selection. And if all vertices in a polygon is selected, then the polygon is selected for features that need polygon selection. And the same goes for edges. In some cases, that doesn't work out as well. So for instance, if I want to select this polygon and I want to select this polygon, I accidentally sort of select the polygon in between, right? Because it has the same vertices. But that happens so rarely that actually doing an action twice is faster than having to constantly be switching back and forth between those modes. So I thought a lot about those things. Other little things, for instance, if I select the surface and right click, so right click is tumble, and then right and left is zoom, right and middle is pan, right, left, and middle resets the view. And if I click on my selection, I automatically zoom in on the bit that I'm working on. So it's really easy actually to just do this and just move around the model where you want to be. So it's kind of the easy stuff. There's a lot of small things. Like for instance, if I select a bunch of vertices here, if I click on this vertex and drag, I create a line, and then I can hook it up and make a poly. But if I click on this vertex, this one, which is selected, you can see I get a different symbol, and that means that it's selected. So when I grab that, I can just move it. Because I find that whenever you do like a soft model, like a face or something like that, you want to sit and tweak a lot of vertices, and then you don't actually want to have to like select and then move and then deselect, select, move, deselect. So you can select everything and just individually move the vertices around. So those are really neat. Another thing you saw there is what I call, instead of feedback, I call it feed before, where you basically, before you click, you see what's going to happen when you click. So you can see that there's a difference between clicking on this one and clicking on that one, right? And the same goes for edges. You can see here, if I click now, I'm gonna split it. If I click here, I'm gonna do another feature, right? So that means that you get very few of those sort of error clicks. And this application, since it only uses mouse, is very sensitive to doing the wrong thing. So for instance, if I select this and I don't finish this selection like that, I do only this, you can see actually the red lines. So now we'll actually delete instead of selecting. So you need that sort of feedback. I'm going to do that. You just saw the pop-up menus. So the middle mouse button is all pop-up menus. If I click anywhere, here I can choose my objects. So I can look at this weird thing. Here's something I modeled earlier. I can select back the object that I had. You can also do some other features, but undo and redo are the main ones. But then you have context-sensitive pop-ups. So for instance, if I select something like that, I can click on this, and here's all the things I can do with my selection. Now you start to see that this application is actually pretty big. So you can do boring things like delete and smooth selection and all kinds of fun stuff. You can reverse the selection, auto crease, blah, blah, blah. There's lots and lots of stuff. But I want to show a couple of them just because I think some of them are really, really powerful. So the first one I'm going to do is I'm just going to move a couple of vertices here. And you can see this shape here is really like crooked and ugly. So we want to fix that. So I'm going to select these vertices here. And then I'm going to click on the surface here. And I'm going to choose flatten. So now I've actually flattened them all to that surface. And this seems like a convenient feature when you implement it. But after a while, I realized it's the mother lode of features because when you do 3D modeling normally, you have to care a lot about like precision and fitting things together and that everything sort of line up correctly. And what I found that once I added this feature, I would just build everything so that it looked good. And then afterward, I would go and say, oh, by the way, the floor is flat and this surface is flat and whatever. So that saves a lot of time. And there's even an extra feature with that I might be able to show. So I'm going to just split this edge, and I'm going to move this one slightly. Okay, so now you can see this polygon and that polygon are no longer flat. So I'm going to select that vertex, and I'm going to say, click on this polygon and say flatten. So now this got moved slightly to be flat to the surface. Well, the problem was we flattened this surface before, right? So now by moving this vertex again, we essentially screwed up our first flatten. Well, this algorithm actually looks at the surrounding surfaces and tries to keep them flat while moving it. So it will actually move it in the plane of this surface in order to flatten it to be flat to this surface. So those little things are really, really powerful. What else can I show you? Oh, I'm going to show you one more thing. I'm going to create something new. So I'm going to just draw a little bit here. Just going to draw a couple of lines. Here we go. I'm just going to move that one down. I hope this is flat now. There we go. Here we have a thing. I didn't make it flat. Sorry. Snap. So there we go. And now I'm gonna check my settings. Oh. Do that. There we go. And now I can click revolve. So now we create a revolve here. I have some cool features. So let's actually just draw a line here. Draw a line there. I'm just gonna build something here really quickly. There we go. Click, click. A little squarey thing. Actually, you can see that it's really fast to build up a little shape or a little something and get it the way you want it. So I can just do this. Let's do that. And then I'm gonna flatten that a little. Oops. And do that right. There we go. So now I have a thing. I don't know what that is. You can rotate it a little bit. Something like that. So now I'm going to, everything works. Move that one. I'm going to select this edge and say select hull, which means it selects this vertex and then keeps going all the way around until it sort of hits an end. I'm going to do the same thing with this one. So now I'm selected all the polygons around here. And then I'm going to click on the back of that one and say deploy. And boom. I've now placed one of these objects on each polygon. Now, this was a technique that I did for this modeler, but it turned out to be super powerful for game development because it's an easy way of building a very coarse piece of geometry, like boxes for houses or something like that, and then just have this sort of polygon replacement thing that you can populate really quickly, and you can get really small models, and your artist can still art direct, right? The windows and stuff are not programmatically designed. It's sort of the programming bit just sort of does the merging. So I'm gonna move on now to my next demo. So modeling is fun, but let's do, I'm gonna kill this verse server and just start a new one with some other content. I think I'm gonna have to do that. So the next tool, part of the chain, is UV mapping. So UV mapping is probably the most boring part of computer graphics. Everybody hates it. So I wrote a really nice editor for doing UV mapping, and I had some features in it that sort of helped so much that I thought, maybe you can do it even better. So here is my tool, and this is the UV mapper. What's cool about it is automatic. So I can actually select a bunch of objects. Here's all my objects that I just loaded. So let's look at this object. Now this UV mapping is completely real-time and dynamic. So let's bring up our modeling tool again. Here we go. And I'm going to select the same object. And when I do this, you can see that it generates a new UV in real time. No more UV mapping. And you can also, the most important feature of this application is animate. You can actually watch it happen. So it's pretty neat. And there's a whole bunch of settings you can do here, but mostly the default just solves everything for you. And especially I wanted a UV editor that was automatic for hard-edged object, because like a face you can sort of wrap around. It's kind of easy to do, but something like a gearbox is impossible because it has so many nooks and crannies. And getting that like properly UV mapped is something you usually have to do by hand, that it's a nightmare. So this is really good for that kind of thing. So I'm just going to bring up another tool, which I'm not going to show you too much now. I just need to fix something for demo purposes. So this is fun, but let's do some texturing. So this is just a prototype. I'd like to finish writing this at some point, but I haven't had the time to do so. But it's a prototype. So here is our lovely object, and I can now add layers of shaders to this. So I'm going to add a simple texture to it just to give it sort of a base. So this is just some dirty rocky thing. And then on top of that, I'm going to paint this object. So now I'm putting some paint on it. So this is brown, gray paint. And I can change the paint color like this. Very nice. And then I can go in and say, well, the edges of this has been cracked, right? Because it's being worn out. And I can also control the surface, how cracked it is. So there we have something starting to look better. And then we want to put some dirt on it. So here's some dirt, and you can control the color of the dirt. So maybe we're sort of brownish. You can do the shadow of the dirt and some other color. Let's do some like weird purpley. Let's give it some artistic flair. And then do this one a little bit yellow. There we go. And I can control, obviously, you know, where do we want this? So we can have extra, obviously, in the cavities where you would have the most dirt gather. You can have on the cracks, which basically everywhere. And then you can fade that out a little bit. And then you can say, well, on the edges of this, you're going to have less dirt because it's going to be like worn off. So there you go. And of course, this is non-destructive, so you can go back and say, well, the blue color was really ugly, so we're going to change that to some other shape. And what's the worst thing that can happen once you've painted your beautiful model and you're super happy with it? Well, then someone says, well, we love it, but change the model and then redo the UV mapping, which means, of course, redo everything. Well, here I can just grab this and say it should be longer, and the UV mapping updates in real time, and the texture updates in real time, and it just solves itself. So this is actually a pretty cool tool also, because the tool uses shaders to do the computation. And what the idea is that you can have a technical director who can write a shader that does a specific effect. And through the shader, you give your inputs tags that the application can read and build an interface for the artist. So that means that you can say, oh, this vec3 is actually a point that I want you to be able to move around, which is like the source of where the splatter is coming from or something like that. So you can really easily sort of design that. And then for the artist, they can just apply it really, really quickly. Because what this is effectively a compositing software. And most compositing software has these sort of node graphs. And node graphs are really good because they're super powerful. But when you have a lot of things you want to do really easily, they're a bit fiddly. And on the other hand, if you want to do something super, super complex, programming is usually better. But artists don't like programming. So I thought I would do like allow you to program the shader, and then you basically just give the artist the controls to be able to handle that. So actually I can check this out. So here is, for instance, the paint shader, which is super simple. So it just asks for the position and stuff, normal stuff. And then it just has a bunch of textures. So it'll ask for a texture. It'll ask for the layer, which is the previous layer that it's compositing over. It has alpha, that is a separate thing. And then it just asks for convex, which is a texture that you can look up to see how convex is the surface at this particular pixel. And then I'll obviously use that to do the compositing to decide where the paint goes and where the paint doesn't go, and so on. And then here's a bunch of values that the uniforms that the user can access. And you can even set some default values. So the default you saw was gray. So now if I do that, I think, and save this, and I quit this and restart it, it doesn't save because it's a prototype. But if I go into my paint, you can see now the default color is red. So it makes it super easy to sort of make new effects. So That's texturing and animation. Sorry, texturing and a bit of shading. So I actually do have, gonna stop my verse server and restart it. I do actually have a system for doing shaders as well, which I haven't been using very much, but it's worth showing off. I'm gonna upload a different set of data, and I'm gonna start a new application. So this is my sort of asset management, data management tool. And here's a scene, and it should be able to run in shaded mode. Here we go. Oh, it's so fast. I haven't used it very much on this computer. So this is a scene, and I can click, and here's all my assets. So I can go through the assets. I can say, here's the geometry. And go into the geometry, see, oh, we got vertex data, we got polygon data, we got material data, blah, blah, blah. Here's a bunch of shaders. I can go into a shader, click on that one, and here's a node tree, so I can do, and this generates OpenGL shaders live. So now I'm just changing a uniform, but actually if you start mucking about with it, you can get some pretty neat things. Let's do something here. You can do this rendering engine is an OpenGL rendering engine, and it has a lot of neat features. Like for instance, this thing here has a displacement map on it, which is real time, so you can play around with that. It actually renders the scene from the point of view of objects. You can do like reflective and refractive objects, like this crazy thing. I'm going to see what I can do. I'm going to start a new object. Do that. Click there. And I'm going to connect it to this thing, and then I'm going to create a new material. Do we have, where did the material go? There. There we go. And then I'm going to need to find this object. Where did I put it? There it is. Here's my object. Is it over there? So now we can go in and build a shader here. So the first thing, oh, of course, sorry, I need an output, which is the output of my shader, and then I can put a, for instance, a color to that. So we can do like that. So now you can see we have a pretty boring thing. Then we can say, oh, it should interact with light. So here's light. So we can do, we need a blender. So we're going to blend light with the color. Hold. Come on. Like that and like that. So there we go. So now we have a shaded object. You can see the background. I can change the color. Oops. That's a later thing. So you can see it's all real-timey. So this obviously is like the world's simplest shader. And then I can add, let's add a reflection to it. Here's a reflection. And let's add a blend to blend in the reflection. So we all know that it's added together. And now it's set to multiply, which is broken. So we're going to change it to add. So now it's super bright, right? Because it's very physically incorrect. So we can actually multiply this with something. So we're going to add another blend here, like that. And I'm going to add something fun. I'm going to add a ramp. Sorry. Here. So this is a ramp object. And you can, I want it to be linear. So there we go. And then I need an input for this, and that drives the ramp where it's placed. And I'm going to add what's called a view, which is the view direction of the surface. It's like the normal. So now you can see it actually fades from red to green. And it's in the XY, and I want it to be blue. So there we go. So now you can see, if you look straight at it, it's blue. And then in the rim, it becomes green, and then red. So that's stupid colors. So I'm just going to make it bright. And make this one really sort of darkish, and then this one ultra dark. So now we have sort of a rim And you can see on the object now the reflection is only in the rim, so we get sort of a Fresnel effect. So it's pretty easy and pretty fun to play, but you can see the highlight around the object. So this tool also does another thing that I think is pretty cool. I'm going to go back to wireframe. I'm going to see the little spaceships here fly around. It's kind of a neat thing. Sure, they always disappear when I want them. Come on, show yourselves. There's a little moon lander. If you click on that one, you can actually... So,
within the tool.
Yes. And obviously, the more stuff you have on the screen, the harder it gets. You can also like zoom in here because the whole interface is scalable, so you get like massive rocks. So you can have fun with that. So I want to take a look at asset management. So this is my billboard that you have here, and you can see it has a material that is connected to a texture. It's a pretty simple thing. So now I'm going to see if I can do this. I'm going to add a tag to this, and I'm going to call it asset, and then priority. And what are we going to do? Let's set this to a string. I hope this works. Boom! Haha! It turned red because all these objects can have tags on them, and they're useful for loads of things, you know, gameplay and whatever you want. But this is also used for asset management in game design. So, for instance, if you have a large team working, you can tag things in the world saying, this needs to be textured, or this is approved, or this is not approved. And instead of having like a wiki or something like that where you have schedules and stuff like that, you store all of that straight in the view. And each user, if you go into the settings here, can set up their own work environment. Let's see. So here's actually the settings, and you can see here's the setting for this one, which is priority. If the tag priority is found in the tag group asset, if the value is critical, make it red. But I can make it, yellow or whatever color I want. I want it green because I'm like mellow. I can put text on it so now it says priority critical. I can even draw a little figure down here, so I can have an icon for it. That might seem like overkill, but often you have objects that don't have geometry, like waypoints or whatever for games. So you can do that. Oh, there's a bug there. Let's turn it back to color. So I really like that sort of that management and things like that we sort of look at as paper products that are different from our tools should really be integrated in our tools, because then you don't have to go through that like, oh, can you fix the billboard? And they're like, okay, we're building a whole city, there's like 1,000 billboards. Which one? Oh, it's the one on the corner by the building. It's like, oh, which one's that? And he's like, I'll take your screenshot and I'll email it to you. And it's like, that's just stupid. This way, you can really quickly you start up the tool in the morning, you can see exactly what you're doing, and you can pipeline it so that I can tag this if I'm a modeler, I can tag this as model complete, and then as soon as I do that, my manager gets, it lights up for him to, approve it, and whenever he approves it, it lights up for the texturing artist saying, hey, you got to start texturing this thing because this model is approved. So you can build a whole workflow there. Of course, this is all like overkill because I work alone, so I'm not really sure why I implemented all this, but there it is. Okay. Let's take a little detour. And this is a tool that I haven't written properly, but I just want to show it to you as a sort of lesson in interface design. This is a video editor, and it has a bunch of footage from my game Love. And you can scroll through it just by moving your mouse pointer. What I really want to showcase here is that what's the most important thing about video editing? Well, I think it's the video. And normally in most video editor, the video is up in the corner, this little thing, and then most of it's just interface. Here, when you move your mouse, you're straight in the video. It's easy to control. You don't even have to look at the interface to scrub through it. And when you go to something like a cut here, I can click. I don't have to click on it, just as long as I click above it or below it, and I can now edit it. And when I edit it, you can see right now that there's 2 additional views down there. And the first one is showing the frame before the edit, and the other one is the frame after the edit. And the big screen is actually playing a loop of the edit over and over and over. And that means I don't have to go through that normal thing of, make a change, move the timer back, press play, press stop, make a change, go back, press play, Here I can just tweak it and I can see instantly, what you see is what you get. And I think these are really, really powerful way of working. So in this tool, I also use only 3 keys. And those are Control and Shift and Alt. And there's an old application called Auto Studio or Alias Studio, which only uses those keys. And I just love that application for the interface. It's like if you ever want a master class in cool interface design. And it's also it was designed in the 80s, so they didn't know what computer programs were supposed to be working. So they all invented their own thing, and it's awesome. So here I just used the Shift and Control to change how I edit this. So now I'm moving the edit, right? And now I'm changing, the in point of the next clip. I can even lock them so that I don't want to change that. So if I click on it, edit, I can move them around. If I shift it like this, I can now slip it. So I'm using the same length of time, but just a different part. And if I do that here, you can see since I locked there, I slipped 2 clips because that edit can change. So if I ever wrote this properly, you would have big chains where you could decide that here's the music. I want that bass line to be attached to this thing when this happened in the film, and I can edit it, but I can never break that sort of connection. And obviously for dialogue and for timing and music and all that stuff. Here's roughly what a transition would look like. And then at any time you can press Alt, and then you would play, and you would use Shift and Control to go back and forth. And one of the features I have here, which is totally broken, is that I can do this. I can draw something, and then when you go back, you have a little drawing there on your timeline. So I really like that idea that notes and metadata and opinions and stuff like that should be right in your tool. It shouldn't be a separate thing. And I really believe that. And if I ever wrote this, I would want you to start with the script and then start swapping out pages for images and stuff like that. And when you get when the actress is supposed to have a dress on, you attach that to the timeline. She walks in a blue dress or whatever, and then the image is right here, so that you have this view of the film you're making all the way through, and all the data wherever you're looking. You can always watch the current version, if that's paper product, if that's maybe some animatics, or maybe it's the full film, or maybe it's without color correcting and then visual effects and the whole thing. And you just keep everything within one tool, and preferably it should be networked, obviously, so everybody can work on the same thing and share information. I think there's half-assed tool here. You can have timelines, and you can add, cut and paste and do stuff. I think I shouldn't show you anymore because it starts to become very apparent how broken everything is. For instance, I think you can quit this. Oh yeah, you can. That's cool. That's a feature I didn't know I had. Powerful stuff. Okay, so now I want to show you what I've been working on. Oh, here, let's show this one. This is a tool that I wrote, super simple, for my previous game, Love. And this is my performance measurement tool. So it allows me to see bottlenecks over time. And this is basically recorded from the players. So it's a PC game, so there's a little file, and I can ask people, send me that file, and then I can see, oh, this rendering is super slow. So for instance here, rendering the sea is ridiculously slow. And here we'll obviously have some spikes that are bad, but the C, the yellow part is all the rendering stuff, so obviously the C shouldn't be that slow. So on this particular machine, the shader was really bad. So it's kind of a fun tool. I'm I have sort of a version of this that it's new that you can do some more stuff on. The problem with that tool is I haven't actually written anything that uses it properly yet. And until I do, I don't want to work on it because I don't like, unless I have a test project for it, it's not worth working on. So that's a small thing. I'm going to go through a couple of like silly things. Oh, I think, I don't have this one. That's bad. Okay, we'll go back here. So let's talk about animation. I am a single person making a first-person shooter. Animation is a nightmare. It's really the part you don't want to deal with. So I realized pretty quickly that I couldn't animate everything the way I wanted. So I tried to do procedural animation. And after a while, I realized I couldn't do procedural animation properly either because it's kind of stupid to do. Like, a lot of things that humans do are very specific. And, like, you know, scratch your head. There's no algorithm for scratch your head. And if you have to write one, it's just annoying. Whereas animation tool is much easier to say, put your hand on your head and scratch it. So this is kind of a library that does procedural animation, but it also lets you do some animation. So here we have our character, and he has a bunch of different things that I've done, like animations. So for instance, I can give him, tell him to put on, to use a gun. So he's actually going to pick up a gun and hold it. Now this is an animation that is not actually static, because if I ask this character to look in a different direction, you can see the gun will follow. And this means that it can be controlled completely by a player. And I can actually show you how to do that. So I'm going to, and automatically from the API that this rendering system uses, I can say something like, use the binoculars instead. He puts the gun back, takes out the binoculars, and now the binoculars are all attached to the look direction. So I can actually go back to my default. He'll put back his binoculars. Sorry about these items that are hanging off of him. That's kind of like objects. It's a little ugly. So I can do animation in a couple of different ways. So the first thing I'm going to do is just add another clip. Here's a clip, and I can now animate. The easiest way to animate is motion capture, except I don't have a motion capture stage. So I just press record, and I say, hello everyone. There we go. So now I can run my little clip here, and I can slow it down, and and I can actually, even while it's playing, I can move keyframes like this. So now he's making a weird motion. I can move the keyframes around in time like that. So it's a really good way to get timing down, because timing is really hard to do when you do keyframing. And this gives me like a rough idea, and then I can go in and tweak it. So that's the first way of doing it. Otherwise, I can also do animation where I do it by hand. So I'm going to show you a tricky problem in game development, which is interacting with static objects, right? Because whenever you do animation, you usually, like if I'm using this keyboard, for instance, I have to stand exactly here because all my body is animated to push the buttons from here. And if I'm standing over here, it doesn't work, right? I start typing in the air. So I'm going to teach this guy to push a button. So we're going to use this object as our dumb object. We're just going to say that's a button. I'm going to make it slightly smaller. There we go. So now I'm going to add a clip, select the clip, I'm going to clear that, and then I'm going to just grab his hand and move it into, this block, like that. That's good. And then we're going to move it forward in time and say, okay, push the button, like that. So now I have a piece of animation where he's pushing the button. Now you notice that all I'm controlling is the hand, and the whole body follows. Because basically what I realized is that there's very few inputs you need for most motions. You just need where the hands are and where the eyes are looking. And then the rest of the body can sort of a lot of times be just animated to follow the hands in a reasonable way. Also, you want to, if you're a little bit more serious, you want to do things like leaning and things like that, depending on if you're running or speeding up or, doing a turn or something like that. But pretty much those are the things you really need to animate. So in this animation tool, the goal is animate as few points as possible, and the other points will sort of follow. And if you need to animate them, you can, but leave them be if you don't have to. So a lot of that is sort of saving time. So now I can basically just go back to my default and say trigger this animation, and you'll see he'll push the button. Right? And actually it was a pretty bad animation. I'm going to move these in and out. So that's basically the fading to and from the keyframes. That's not a keyframe. There we go. So now default and play it back. There we go. Push button. Right? The cool thing is, of course, if I move the button over here, push the button. Or let's say button is smaller in ceiling and like that because we're like in a cockpit or something. Push the button upwards, right? Or like I'm in the middle of battle. I'm holding my gun. I'm out to get you, but I really need to push the button, right? Or I'm hold on. I'm running around. There we go. So now he's walking and he is pushing the button. Reach. No. There we go. So all of this is now controlled completely through the animation system. And of course I can, this might be a player. So he might be doing, this. So now you can see he's walking forward and then backward when he turns. And if I do this, he'll do that. The turning isn't perfect. I'm sorry. So this was a really cool project, and this was what I would use for my game Love. And it worked pretty well. I do hit detection as well on the ground, so that you get proper foot planting. So some things that are hard to do in a mocap world became really easy to do here. Obviously, this character is kind of chunky because he's only a biped human being. He also is really bad at doing things that don't involve standing up. He can do duck. Let's see if I can do that. Yeah, there we go. But you can see you bugged out a little bit. So it wasn't really great, but it worked well for my game. So I wanted to write something better. So that's part of what I've been doing lately. So that's I'm going to show you soon. I just want to show you that, of course, I can add my setup here. So I can obviously make his legs really long. And as he walks way slower, or make him really silly, and make the arms long. So let's have him. He can still reach it because he's got long arms, and yeah, you can really ruin him. Like put his neck up and make his head large. So yeah, you can really screw it up. But this was cool, but I wanted to go to sort of the next level. So now I'm going to show you, there's a lot of stuff here. This is probably one of those things where I'm going to have to, I never know what the debug setting is for this thing. There we go. So this is my visual effects application, and I find that if you're implementing pretty much any gameplay, it's usually really easy to do. Like if you imagine the charge up shield of Halo, that's like 10 lines of code, right? It's basically just like when you get hurt, it goes down, timer if you haven't hurt in a while, blah blah, go up, done. It's super easy to do. The problem is that actually implementing that is hard because you have to have a little piece of graphics, there's sound, there's all these different pieces that come together, the animation for a little thing, and especially for gameplay development, it's really nasty because you have an idea, you want to try it out and see if it works, and you don't have to spend like lots of art time and stuff. You just want something that works and be able to test it really quickly. And we spend a lot of times, talking to each other about like, oh, this shader should change here because you're pushing the button to the elevator, and then it should turn a different color, and then it should say ding when it comes there. There's a lot of like programmer, artist, designer talk that has to happen, and talking is really slow. So what if you could do it in a better way? So I built this tool, which is sort of a weird tool because all the tools you've seen so far has been super like artist friendly, and they're all like about helping the artist. This is a tool that is more of a TD tool, which is more about power and being able to do weird stuff, not being able to do sort of the regular things. So I'm going to see if I can select. I'm going to create a new entity. If I have, oh, here we go. Let's create a new one. So here's an empty space, and what you do here is you create entities, and I'm going to create something super simple. I'm going to add a component, and here's all my shaders that I've loaded. And I'm going to add a new shader, just show you. This is a broken interface, sorry, this is a new. But you basically just give it a name, load a shader, and say if you want an object shader or a sprite shader. I'm going to go into why those are different. And then you get a new thing. So here I'm going to show you the simplest shader I have. No, I'm not. I'm going to show you a more complicated one to start off. So I'm going to create a sprite. So this is a sprite, and it gets created here, and I can now go in and actually all the interface you see here is built from the shader. So these are all the values that are per vertex values. So you have the UV, you have some color, you can turn off and on if you want to draw it. You can say the size of the actual thing. And then I can go into the actual draw mode, and here's the settings for the drawing. So I can say, let's put some textures on this. I'm going to put a couple of noises and a texture. I can say this draw call needs to have no depth test, and here I can do the different settings for what kind of, I'm going to do 1 for my source and destination, blend mode, there we go, and then here we go. So now imagine you have a character that has a little light on it. In rendering terms, you don't want to have a draw call for that light because it's just a little sprite. It's only 4 vertices. It's going to be really slow. So what you want to do is you want to collect all the little lights that all the little characters have, make an array, and then say to the graphics engine, draw this array. So some of the objects in your world are going to be where you want to upload the geometry beforehand, like with meshes, and you're going to basically say, trigger, draw this mesh. And sometimes you're going to want to generate a mesh and just say, draw this mesh. So what this object is a object that basically creates a thing in an array and then tells you to draw it. So each sprite only has different vertex data, but the same draw call data. And then you have other objects where the draw call data is different for every object, for geometry and things like that. So let's make something here. So the first thing we can do is just edit stuff. So for instance, here's the UV mapping. So I can just, let's just UV map this a little bit. I'm just going to select a piece of the, this is good, no? Where am I? Sorry. There we go. So now, sorry. So here we have now our sprite. I can take down the brightness a little bit. You can see also this has my new user interface library, so it's much slicker. Everything is scalable, so you can, if you're blind, you can make it larger, which is really neat because, different sizes. And it also runs on like tablet devices because it's all multi-touch. So for instance, now I can say, oh, I want this other to rotate. So now I have an operator here that rotates this layer of UV. And I can say, oh, let's connect that to time. So now we have a animated thing. And I can control the speed of that. So that looks kind of neat. And then, of course, I can turn that down. Let's take this layer, which is also a blend mode, and let's connect that to a blend. So now I have 2 different UV maps, this one and that one. And I can say, oh, I'm going to move this one over here. There we go. Like that. And now if I control my driver here, you can see I'm scrolling it. So let's put that on a loop. So now we have a interesting effect. So one of the big inspirations for this tool was actually Diablo 3, because Diablo 3 has a million different spells and things, and I always thought, how do you solve that problem, right? Because they're not geometry, they're not sort of something you usually get out from Maya or Max or something like that. It's sprites, but it's like has all these parameters, and the UV should be animated, and the shaders should have like animated parameters, and it's like it's this weird thing, and you want to really be able to play around with it. So I actually went to Blizzard and saw their tools, and their tools is pretty much like do everything by hand. It takes 7 years, but it'll be awesome. And if you own World of Warcraft, that's okay. If you don't, you want something else. So this is something else. This obviously is an object, and it's now called a name. We call it, say, puff. Okay. I crashed it? No. Sorry, I used the word P. P saves. So that's whenever I type P, it saves. It's not finished, this application. So now from my application, I can actually call in, I want an object puff. But how do I place it? How do I change it? Well, it has a bunch of values over here, and that's the stack of data that this object sort of operates on. So the first one is sprite triple, which triple is the shader, and then vertex. So I can change that to center, right? So now from the game, you can actually go in and say, I want to create a puff, and I want to set this instance of puff, I want to set the center to this XYZ coordinate. And then you can animate that bit, right? Now that's really cool, but what if you want to do more complicated stuff? Okay, so let's look at the color here. I want this color to be two different things. So I'm going to put a blend here, and I'm going to say, I'm going to do like fire color, like, right? Because this is a fire effect. But then let's say there's like a magical thing you can put on it that makes it an ice effect. So I'm going to give it an ice color right there. So now I have this driver that fades between these two values, right? And that driver is here. So here I can say, name that, say, element, and that now controls the elemental force of this, effect. And I can even change other things. So let's go into the size here and say, I want to blend the size as well. Let's do a blend here. I want to have, let's center those. So I want this effect to be like that, and the other to be, okay. So now I have a blend between these two shapes, right? And I can just click here and say, oh, grab that data from that element thing. So now you have one handle that animates multiple things. And this now can control, you can make as many as you want and make really, really elaborate things. So this tool is sort of a plugin based system. Every little thing here is a plugin, basically. So I am going to do IK, I'm going to do the whole animation system in this, so that you can do things like, if the character's tired, he walks, his head is slightly lower, or, the shader for the blood on his shirt is different when he's hurt, and, and artists can really, like technical directors can really go in and fix that and add stuff. And also, another feature of that is that the engine can export out the data sets for all the inputs here. Which means that you as if you come from the engine side, you can say, well, this character has all these parameters. I'm just going to tell the artist here, load in this file, and you get them, all the values, and just connect whatever you want to it, and automatically it's just going to work. Because, and if we add new ones, it can be from the AI system or whatever. You just plug them all in. And that's something I worked on before, which is that I feel it's really good if you have a pipeline for games, if it can work both ways. So sometimes you have an artist working on something and you want to give that to a programmer. But sometimes a programmer is working on something and needs an art assets. So what I try to do is I try to have stand-ins. So if a programmer says, I want a tank here that is going to run down the street, you basically say, oh, that's a box that is this big and, it's a geometry and has some stuff on it, right? And then if that doesn't exist in the repository of assets, you'll just get a box. It'll be a poly model. It's super simple. It'll be a green box, basically. But then when the artist comes into work, it's like, hey, I saw the game. It's really awesome. We got the tank in. It looks terrible. They don't even have to ask what the naming of it, how to deal with it. They just go into the repository and it's already there. And they can just start remodeling it into a proper tank. And they have the dimensions, they have all the inputs, and they have the gameplay parameters. And they don't have to actually talk to anybody. You don't have to have a meeting of like, what's the naming convention for X, Y, and Z. And that to me is really important because it means that the artist can, if the programmer opens up and says, oh, there's already the tank that I need, well, just use the name and use it. But if a programmer needs a tank and there isn't one, they can just sort of create one. And that to me is really, really powerful because it means you can sort of be in the zone and work on what you want to work on and not have to bother with anything. It's also really neat when you get stupid people like accidentally deleting stuff because the system runs always. It'll just, give you the default values, and then you can print out like an error list that says, the previous run we had, these assets were missing, and we put in the sort of default ones so you don't accidentally ship with default data. So this is one object, and that's cool, but all these, you can see the little ones here. So you can actually press 0 after that, and now we have 10 positions, and therefore we get 10 sprites, which is kind of neat, but it's even neater when we create a new entity. And I'm going to create the simplest thing I have, which is my dot. So this is a sprite dot. It's just a shader basically saying if you're outside of the circle, don't draw me, and has a color. Amazing. So now I can create another component. I'm going to create a particle emitter. Yay! So here's a particle emitter. See, it's spewing out particles. And I can go back to my sprite and say, oh, wouldn't it be cool if this position, instead of this one position, was this output? So now we have a particle system. We can say, wouldn't it be cool if instead of 100 were 10,000? And sure, that would be cool. I think this is a nice machine. Can do 100,000? It gets a little slow now. No, not really. Make it smaller. This whole, yeah, it's slightly slow. Let's go back to a mere 10,000. So now I can, all this interactive. I have one color here, and I want to animate the color. It'd be cool to animate it. So I'm going to put an animation here, and I get an animation. So now I can animate the color between these two values. But then I go up here into the color and says, let's not have one color. Let's have 10,000 colors so that each and every one of these gets its own color. So now they all have their own color, but they're all the same color. So this driver that drives where I am on this animation, let's connect that to the particles to get the age of the particles. So now you can see we're animating them over time. So I can start out yellow, I can put a keyframe here, let's make them red. Let's make this something like that. Let's put some artistic purple. Oops. Something like that. And then let's close that. Let's the size, they're all the same size now, so we're gonna do 10,000 different sizes. It's actually really neat. Like, if you want to, you can do something like this, like 2 sizes, right? And I can now, let's see, make this smaller. Am I doing it right? Why is it so big? Oh. So actually now you can see I'm doing this. I actually have 2 different colors, 2 different sizes. So that's something you can do sometimes when you like, I want like 1 million little blades of grass, and I want them to be different colors, but I don't want to evaluate a new color for every blade of grass. I'm gonna have 10 different ones that I evaluate, and then I can animate those 10, and then the million grass will each have their own. Let's actually do 10,000 here as well. See if I can do this, and then animate this. It's behaving weirdly. I don't know what's going on. So now I'm going to connect this one as well to the particles. So I can collapse this one, and then I can do something a bit. So now you can see they're starting out collapsed and then become large and then small. So And then the particle emitter, let's give it some age so they last longer. And you can play around. Now you can start seeing that it is quite a bit of particles, actually. 10,000. And you can also do things like, now moving where I'm aiming this, right? So this is the target, so I can put a wiggle on that. So wiggle is a function that basically just wiggles around something. So here we have the center, and then I can drive how I'm wiggling. So you can see, I'm going to put that to time. And you can see I'm wiggling. I'm going to slow it down. There we go. And then size it up. There we go. So now we're getting sort of a interesting thing. It can sometimes be quite bad for productivity, this tool, because you just play around. You can make very pretty things. And then I add another component. I'm going to add a piece of gravity. Here we go. So this is gravity. I'm just going to have a little less gravity. There we go. And then add a collision. So now we're colliding with the ground. Put some bounce on it. So now you can see we're doing something fun. And then add another, whoa. This is turbulence. It just ruins everything. Because the strength is too high. There we go. And it's like less turbulence, but still enough to ruin everything. There we go. I don't know what this, wow, looks kind of interesting. Weird. Let's see. Oh, this is cool. I can actually show you this sliders. These are pretty nice. They're directional. That's an interface thing I invented. So normal sliders take up a lot of space, and these are basically point shapes, and you go from 0 to 10 or to 1. And then you have all these snaps so that you can get actually 25% or whatever you want. And if you, like now I want to have a very, very low value, I can go really, really close to the edge here. Get really high precision, which you wouldn't get on a small slider. So, wow, what's going on? Looks weird. Let's actually kill this one. Let's behave like normal. I'll add the one that I like, which is the rotate one. So, put a force here, and you can see it starts rotating. I can, whoops. Here you can create sort of a cool thing. Let's actually go into the particle emitter and just add the spread and the speed. There we go. Starts to, yeah. Not just for work, but yeah. So yeah, that's kind of my demo of this tool. So lots more stuff is coming. Is anyone here a programmer? Yep. A couple? Okay. I'll do a very quick show of the source code for this project. I'll show you how easy it is to work with. So basically, you just load a session, create a session and say, oh, I'll load this file that I got from the artist. Launch a bunch of threads, because it's multi-threaded, so all these things will be automatically split up into multi-threads. That's another thing I want to do, is actually keep the game loop super simple and then do all the graphicsy stuff on separate threads. And then you can just enumerate through all the entities that are available, or you can just look one up by name. And then once you get them, you can just say, create me an instance of this thing. And once you have an instance, you can either destroy it, or you can say fire and forget. So for instance, you do like a bullet hitting a wall, like the game might not want to keep track of the ID and know when that has finished playing. It will just say, draw this, and once you're done, delete yourself, because I just want to set you once where you are. And once I've set you, go and disappear on your own. And then once you've done that, you basically can just set different kind of inputs that, the instance has. So it can be all kinds of stuff like positions and colors and what have you. And then there's a loading things. So when you load in the file that contains your visual effects, it will give you callbacks like, here's my text, here's the textures, here's the geometries, here's the shaders that you need to do in your engine. And you can load them and however you do that kind of stuff, and you give the system back an ID so that they can call on you. And then here's your rendering loop basically saying, oh, I want to begin drawing now. And then it just says, here's the state you need to draw, state number 1. Here's the shader for that state. Here's the geometry. Here's some data you might have to update the geometry with. Here's the uniforms you need to set. And then, boom, draw. Here's the range you draw. Done. And then it just keeps looping through that. So writing a rendering loop around this is super easy, but it's not bound to OpenGL or DirectX or whatever, so you can have the same effects on different platforms. So that's kind of neat. I think I'm getting close to the end now in terms of demos. I had my cloth demo. That's cool. I have cloth. I'm especially proud of the wind simulation, which is really good. But that's too interesting. So finally, I think we have some time, right? A little bit.
10 minutes.
10 minutes, okay. So I'm going to show you what I'm working on right now, which, oh, sorry. We're back to this. Which is the game I'm working on. So this is the least visually impressive thing you're going to see all day. And it's a real-time strategy game, and it takes place on a planet that has stopped for some reason rotating, and that means that one side is always in light, and everyone who lived there had burned to a crisp, and there's a dark side, and the dark side everyone has sort of frozen to death, except the people who lived sort of right on the rim. And the game takes place like 20 years later, when people are starting to explore the dark side of the planet, and they are, looking for things and starting to fight over the resources they find. So that's kind of the game. The graphics are super simple because I'm mainly working with gameplay. This planet I had to make because, hey, I need something pretty to look at. So I want to show you a couple of things. I want to show you a little bit of the game first, and then after that I'm going to show you a little bit of the tools. So I'm going to show you basically how this game works. So this is a level. Right now I'm playing in a weird mode, which is where I can control both sides of the game. And that's just for sort of demo and testing purposes. Normally you wouldn't. And the whole game takes place in darkness. So most of this level is dark, except for these light sources that light up certain areas. So normally, if I were the red team, I would not see the blue team because they're in darkness. And my units won't do that either. So if I move a unit over here, move a unit over here. Oh, sorry. There we go. These guys, they can't see anything. And I move this unit over here, and they still can't see each other. But then, of course, when I move out here, they start shooting at this guy. And he needs to run really quickly. Now you can see that they're actually spraying to the last known address. Guess where I made the particle effects? So I can bring in another unit. So these guys are kind of the normal marine units. They're fast firing, they're fast moving, they have a fair bit of armor. Every unit has like a special feature, which is the middle mouse button, and they can cast a spell. So these guys have this spell where if they suspect someone is here, they can throw a flare over there, light up the area. And now this guy's toast unless he moves quickly, which he won't because this is a demo. So this guy, on the other hand, he is a jogger, and he has a really high-powered rifle. So I'm gonna just take this guy and help him out for a second. And this guy, who's our friend, he's gonna throw a flare and show these guys where they are. So this guy now starts aiming, and boom, he has this really powerful one-shot. He has some weird gameplay where he actually, let's see, if you do this, he can actually move while aiming. He'll keep aiming. Oh, shit. Sorry, I messed up. Move over here, I can do that. So here I can take him out. Actually I can't because it's slightly too much armor. I need to have 2 shots. So this guy has a spell as well. He can throw one out here, and that takes out the light sources because he has an EMP. So now he can sneak across and no one will see him. Haha. how sneaky. And then, of course, these will turn off on in a second. Also, this guy, who is a fender, he can't shoot anything. But, on the other hand, he has a shield. Oh, this is a new feature. Units can actually carry each other. So when a unit dies, you can carry him home and heal him. Which turns out to be really cool because it basically means that there is no, like, let's see, I'm just going to go, you can actually kill people walking up to them. Ha, kill. Places where you've had battle becomes really contested because there's a bunch of dead bodies there and you want to bring them home to heal them. So that creates really sort of dynamic gameplay, which is really cool. And he has a special feature. He has grabbed a bad guy. And that is this, which is visually very unimpressive. But basically he can send a missile. And it takes a long time to charge up, so people can sort of move out of the way. But it's a really good way to sort of dislodge an enemy that is sort of encamped somewhere. No explosion, it's coming. And then finally this one, which is my latest character, he's got a weird field around him, as you can see. And he is useful. Actually, I'm going to use this guy. Because if I put a unit in here, he starts moving faster. This is a speed field. So now if he fires, for instance, you can see fire in the hall. And also, he can switch to another mode, which is this, where time stops. Sorry, I can move this guy here and then turn this sort of mode on. So if I now fire, you can see the bullets stop there. And then when I switch this on again, you see. So you can actually capture enemies and freeze time around them, shoot at them, turn on time, and all the bullets will hit them. And then there's two more modes that he has in this field. Sorry, this is fairly new. There's this one, which is a teleport field, so you can teleport within this field. So actually, if you have two of these units put both in teleport, you can sort of create a wormhole and ferry units quickly over like this. And then finally, the other one is like a brittle field that makes everything brittle, so you can shoot. Everyone takes more damage when in this field, but you can also shoot through walls. So you can sort of walk up to a wall, start shooting through the wall, and then when the enemy starts firing back, you turn it off so they hit the wall and, stuff like that. So this will be out at some point in the future. I'm still working on it, as you can see. If we have a moment left. Sorry?
You want to take any questions?
Let me take questions in a second. I want to return to menu and then just show you. It has a full editor. So this is the editor for it. So you can, build your own levels and upload them because it has like a server system. This is really neat because it has like guidelines. So you see all lines gets extended. So I can grab that one and put it right there where these two lines connect. So you can build really complicated shapes without using a grid. There is actually a grid you can call upon if you want one, but it's really neat. And then you can place items and characters and stuff like that. Sorry. There we go. There you go. This little unit guy. Can move him around. So it's a full editor. And you can place pieces of rock. This is a rock, a square rock. But you can actually start shaping it any way you want. So that's it. So that's this tool. It's coming out soon, I hope. So questions, I guess.
With the light and dark, couldn't you technically be next to an enemy and wouldn't even know you were there?
Yes, and that's why I've added a feature for that. So let's actually edit. Let's go back to our sandbox mode. Actually, I can do this. There we go. So you can see that right now they're all standing in this color, but each little unit has a circle around them, and that's their sort of awareness circle. So if you walk into that, you will find them. So you can't actually bump into people, but it's really, really small. And it still counts as darkness because a lot of the weapons and things like that work differently. So The sniper will always track only something in light, whereas you have to track, move it yourself to track in darkness. The guy with the machine gun will actually spray in darkness because he can't hit as well, so fewer bullets will probably hit. Now we're actually watching the AI play. It's a little bit broken, but they're working on it. Taking over buildings. So the game is going to be about taking over buildings, because you don't want to have a game that is about killing all enemies when you can hide an enemy in a corner in the dark. That will become annoying. So that's it. Any other questions?
Have you tried to use your toolset for like a team or anything like that?
Not really.
Okay.
I would like to. I'm going to force a team to do it if I ever get a team. It's going to be super exciting to see them hate me. My team, so a lot of my tools are really good and I use them a lot. So they're in a way production proven, but I don't have like proper manuals for stuff. And sometimes like I have problems where I update my libraries and my tech, and like you saw the amount of tools I have. Like if I have to, like if I rename a function, that's like 10 different tools that I have to go in and make sure they run. So sometimes I have that issue of like maintenance. Like I feel sometimes like I'm drowning in maintenance of old applications because I have so many of them. So that's kind of an issue that I would really like to get resolved if I could hire some people. So these are very friendly, these guys. They're not fighting very much. The AI doesn't know how to use this unit because it's new. So, any other questions?
Are you doing anything with sound in terms of like physical modeling, or doing all sample-based stuff?
No, not physical modeling, but I do have a sound system that is full 3D sound with Doppler and all that stuff. I have a, if we can be allowed to do a short programming session. So I have a bunch of libraries. I can go through them really quickly. First one's Forge, which is just sort of math and defines. So I define things as true and false here. I have my own memory debugger. I have random number generation, which is really good. Rate casting, intersection, some stuff like that. And then I have Betray, which is my version of, you could say, Glut or SDL. And it's really neat because it's super small. It's only a couple of files. And then it has a plugin interface that allows you to add new features. So that means each plugin can support a SDK, for instance. And then you just add the plugin and it will work, and you don't have to build the plugin in order to build the application. And that supports multi-touch. It supports multi-display, input like sticks and things like that. And it also has a sound system, which is, you can either, get streams or give streams. You can place streams in a 3D environment. You can do, with Doppler and things like that. You can also do with samples. So you can basically upload a bunch of samples, get IDs back, and say, trigger this explosion. And then it just happens. What else does it do? It can take over the entire screen. So you can have a plugin that does color correction for your entire screen. Or you can do, actually I have one that does just screenshotting, right? So it actually says pipe all the output screens through me. And there's a sort of a neat trick I do where when you draw an OpenGL to a frame buffer object, you will actually, whenever you set it to frame buffer 0, which is the screen, it will actually not draw to the screen, but draw to a texture, and then the plugin will take that texture and draw it to the screen. So, for instance, I have a screenshot application where you press a button, and for one frame, it fools you into thinking that the screen is 8K large, right? And then it renders one 8K thing, and then it samples that down, draws it on the screen, but then takes the 8K and actually saves it to a file. So that's how you do like screenshots for print or stuff like that, where you need like super high res. So there's some neat features like that. What else do I have? I have Imagine, which is Betray, but without a screen. So it's like everything you need from a platform, but that doesn't need need a screen. So for instance, Threads supports that are multi-platform. You might want to write like a server application that doesn't need an OpenGL context or something like that. So this has timing, it has a loading of libraries. I have a data for image and video, so I can load, and it's a wrapper around FFmpeg, GDI, and a couple of other plugins so you can have for loading images and sound. I have Verse, of course, which I showed you, which is the networking, and I have a wrapper for that does all the storage, called Enough. I have a rendering library called Relinquish, which is a wrapper around OpenGL, and it wraps it so it looks more modern, so it's actually going to be for future OpenGLs, but also it takes out all the difference between ES and regular OpenGL. So if you make an application with this, it will work on ES as well, which is in the future not going to be an issue because they're changing that, but right now it's an issue. So I deal with that. Then I have Seduce, which is all the graphics you've seen in terms of interface. So, drawing text, which is scalable, editing text, translation system, pop-up menus, interface stuff like cameras. You have backgrounds, drawing surfaces. Here's all the view stuff. It's way too much. Full 3D manipulator suite with like points, XYZ, like spaces, rotation, scale, all the stuff you would need to build a 3D application pretty much. Because as you can see, I make a lot of 3D applications. So, and then, yeah, lots of stuff. And then finally, I'm going to show you this. This is my favorite of the neatness one. So this is my binary packing, which is called Unravel. And Unravel is going to grow to something large and massive in the future, but right now it's just a packing library. And what it basically means is, if you've ever done binary files, you know that binary files or binary networking is really great until you do something wrong and you start reading data the wrong way and it's out of sync with how you wrote the data, and then you're screwed. And usually when it breaks is not when the error was, because you start reading data the wrong way, got corrupted somewhere, and at some point you're making allocation for 4 gigs of RAM and it says, no, you can't do that. And you're like, why am I doing that? Why is the data wrong? So what this does is allows you to start a network stream or a datagram or a file handle for reading and writing. And then it has a bunch of these pack and unpack algorithms where you can pack data. And it does that always big endian, so that no matter if your machine is big endian or little endian, they'll be compatible. So you don't have to ever worry about that. But what's really neat about it is you can also put a name to each one of these. And then you turn on the debug mode. And that means that whenever you save any of these values, it's going to save a header with the type and the name. And then when you unpack it, it's going to match the type and the name. And it's going to stop and say, it broke on this line. The data was a float called, position. And you try to read an integer as type. That's wrong. And we'll actually do that. And actually, these ones aren't functions. They're macros. So if you go into the secret debug one, that is hidden from the user, of course. Debug. It looks like this. So the actual function, the internal one, has file and line. And then with a macro, I do the macros file and line. So the error message will actually say in file this and this, on line 37, this is the problem. And that's like such a lifesaver. Can't believe how many times I wanted this and how many times I've used it since I created it. It's totally awesome. So I can send you the source code if anybody wants it. It's really nice. So that's that.
I think we're out of time.
I think we're out of time. So thank you very much for coming. And I hope you return for the sequel this afternoon. It's going to be even better.